Okay, we're going to be evaluating, giving our answers as exact values. Now, in this video today, we're not going to be using the same formulas that they use in the textbook because we want to use the formulas from the formula book. So, first thing I'm going to do is I'm going to look at the numerator of this. So, our numerator is sine 85 degrees plus sine 35 degrees. Now, I'm going to look over at my formula book and I'm going to try and match it to something. So I can see that I've got terms over there where it's the angles inside the bracket adding, and then I've got terms to the side. It doesn't match anything there because I want to have sine plus sine. So if I look down to the product identities, I can see that there is the third one down that looks like this. Sine A cos B is equal to 1/2 sine A plus B bracket plus sine bracket A minus B bracket. Okay, so that will match this top part here. So all I'd have to do to get that to match is to take this to the other side by multiplying it by 2. That will get rid of it there. So now we're going to determine what our value of A is. Now we know that A plus B should be equal to 85 because that is there. And it should be the bigger one because if I have something and I add something to it, it'll turn into a bigger number, not a smaller number. Unless it's negative, but whatevs. Okay, so now I've got A equals 85 minus B. Now I'm going to do the same thing for the second equation, but I'm going to use this is equal to that. A minus B is equal to 35. Therefore, A is equal to 35 plus B. Now I'm going to solve simultaneously by making this one equal to that one. 85 minus B is equal to 35 plus B. Take the B over here, I'll be given 2B. Take the 35 over there, 85 minus 35 is 50. Then I'm going to divide this side by 2, so I'm left with B is equal to 25 degrees. Now I can determine the value of B. Okay, and I'm going to do that by substituting my value of B into any of these equations. So I'll throw it in this one. A equals 35 plus 25 equals 60. Okay, so now that I've got that, I can show that my numerator is going to be equal to 2 lots of sine bracket. A is 60. Now that's an exact value, we know that one. And the other one is cos 25 degrees. Okay, so next thing we're going to do is we're going to start looking at our denominator. Okay, so when we're looking at our denominator this time, we've got cos 85 degrees plus cos 35 degrees. So I'm looking for the one where they're adding. So I'm looking at my formula book. Again, I'm looking at product identities. Now the first one has got cos minus cos, so I don't want that one. The next one down has got cos plus cos. So I'm going to state that formula that I see there. Half cos A plus B bracket. Oh no, sorry, that's minus. Plus cos A plus B bracket, and that is equal to cos A cos B. Now to get this the same as it's written here, I'd have to move this to the other side. So I'm going to take that across by multiplying the other side by 2. Now I can use my values of A and B from over here because they'll be the same. So let A equal 60 and B equal 25. So now on the denominator, cos 85 degrees plus cos 35 degrees is equal to 2 cos 60 cos 25. Now, very quickly, you're going to see why this is such a good process. Because remember, back in the day, we didn't have calculators to do everything, so we had to do it in exact form. So, I'm going to substitute the numerator and the denominator back in, the numerator being this one, the denominator being that one. So, 2 sine 60 cos 25 divided by 2 cos 60 cos 25. Now I'm going to look for the things that I can cancel. This and this can cancel, this and this can cancel, and I'm left with sine 60 divided by cos 60. Or I could say that is root 3 over 2 divided by a half. If I change this to a multiply, I flip this fraction, so that would become root 3 on 2 times 2 on 1. Cancel, cancel, it's equal to 1 nice root 3.